On July 2nd, 1937, 75 years ago last month, Amelia Earhart, along with her navigator Fred Noonan, disappeared while attempting to fly around the world. Their last flight was from New Guinea to a very small island in the Pacific called Howland Island. They were flying an airplane like this called an Electric 10. No trace of them has ever been found. Last month, there was an expedition that set out to locate wreckage of her aircraft. And this expedition was the 7th expedition of the group called Tiger, which has a theory that instead of landing at her destination island, Howland, she ended up at an island 400 miles away called Gardner Island at the time, and now called Nicomaroro. This is their 7th expedition to that island, and so far they found nothing that shows conclusively that she was ever on that island. So here's what their theory entails: that Amelia Earhart and her navigator are flying in this direction from New Guinea to Howland Island, but instead of landing there, they ended up flying all the way down here and landed on this little island, Gardner Island, 400 miles away. Well, there are a number of problems with this theory, and one is that only 7 days after the disappearance, 3 Navy aircraft circled over the island and other islands attempting to find Amelia Earhart, and they observed nobody on the ground, nobody waving back, nor did they see any wreckage of the aircraft at that time. The explanation given, however, by the proponents of this Nicomaroro theory was that Amelia and Fred had probably already died, possibly from lack of water, since there was no fresh water available on the island. According to Air Force Survival Manual, however, a person should be able to survive 9 days and possibly quite a bit longer without any water at all under the conditions that they were encountering on the island. In addition, I pointed out that they could have manufactured a saltwater distilling kit out of the skin of the aircraft, which is just thin aluminum, which can be cut with a regular knife. Most people don't understand that about aircraft. The aluminum isn't a whole lot thicker than that found in beer cans. Anyway, the video right now is to show how easy it is to make a saltwater distillation still. You may have in your mind's eye a still consisting of copper tubes and spirals and bubbling water and all kinds of stuff, kind of like out of a science fiction movie. But in fact, the reality is quite a bit simpler than that. I don't have any aircraft wreckage here to cut up and form into a still, so I'm going to have to use the items I do have at home here, which are just the normal things found in anybody's kitchen. Okay, I've laid out on the table here all the components of our proof of concept saltwater distillation still. And here's what we have. We have 2 pots. One pot, this one, will contain the salt water from the ocean that we're going to boil. This other pan, we're going to use the bottom surface of that pan as the condensing unit. As the steam comes off of this pot, it'll end up on the bottom of this pot, condense, and run off into our collection device, which we're going to use your standard bar type jigger, which holds 1.5 ounces. It's also marked at the halfway point, which is 3/4 of an ounce, so we can measure the output of the still. I also had a small piece of aluminum laying around that I cut so that I can use it as a stand to hold the 2 pots in the proper orientation, and also a couple small pieces of aluminum foil to act as a water collector, and also to make sure the steam doesn't bypass the condenser unit. And one other thing I had to fashion was this piece of wire, which is just the only purpose of which is to hold the condensing unit in place so it doesn't slide off from the evaporator unit. Okay, I'm going to go set this on the stove and we'll get started. Okay, we put the evaporator unit in place on the burner. Just again, our pot. This aluminum at this end is going. Aluminum foil at this end is going to be a place for the water to drip. And we have a pot of seawater here. Our magic seawater. We added salt to it. And what we're going to do is we're going to add this to the evaporator unit. And I don't know, I'll put in, say, 3 or 4 ladles so it doesn't take too long to bring it up to the boiling point. In real life, of course, you'd probably fill it all the way up, so you wouldn't have to be doing this all the time. Okay. I've now placed the condensing unit on top of the evaporator unit, and in order for the condenser to work, it has to be cold. So we're going to take some more of our room temperature water. This water is actually, well, let's see, how warm is it? It's okay, about 83 degrees, which is almost exactly the same temperature as the water found at Nicomororo. It's about 85 degrees there. The warmer the water is, of course, the quicker it'll come to a boil. Okay, we're going to put some of this cold seawater into the condensing unit. Okay, and we're going to, component was this piece of aluminum foil I put across the back end of this assembly so that the steam is directed to the bottom of the condensing unit as opposed to just escaping freely. And we'll put our, it's empty, come on, no water in there. And we'll start our timer going here, and we'll start the fire. Okay, and we'll come back when the water's boiling, about 3 minutes probably. Okay, nothing's happening yet. Not surprising, it's only been a little over a minute. Okay, about 2.5 minutes have gone by. Nothing's happening yet. We have to get the water to boil, which means it has to go from the 80 degrees approximately that it was at all the way up to 212. It takes a little while to get it started. Okay, it's been about 4 minutes and we're starting to see, here it comes, there it is, the first drop. Okay, here comes the next one. See how this is working. Okay, a little rivulet runs down. Okay, it's working as designed. Here comes the water. There we go. We got water in our cup now. It's been 4 minutes and 38 seconds. Okay, this is working pretty good. See the water running down. Okay, it's really going right along. It reminds me of the old percolators. If anybody's old enough to remember those commercials for, I think it was Maxwell House coffee. And you can imagine the anticipation of Amelia and Fred waiting for their first drink of nice fresh water, knowing that once they get this working, that they'll have an unlimited, unrestricted supply of fresh water. All they need to do is gather wood from the wooded island which they're on and keep the fire going, and they're guaranteed a sufficient drinking water to last indefinitely. In addition, there's all kinds of fauna, animals on the island, big crabs, the biggest crabs in the world, that the islanders consider a delicacy, so there's no reason for anybody to go to bed hungry either. Okay, now one thing we have to do is the water in the condensing unit absorbs heat from the steam as it condenses, and as you can see, it's getting hot, 122 degrees. So what we would do then is we would ladle this hot water off into our evaporator unit, and since it's already heated up, it would take less time for it to boil. So the heat energy isn't going to waste. I'm not going to do that right now. I didn't include a trough or anything for adding the cold water, or correction, the heated water to the bottom. I'm just going to add some more cold seawater to the pot in the condenser unit here to keep it cool. But I say in real life, you wouldn't waste this hot water. You'd add it to the evaporator unit. Okay, we're getting really close now. When the water goes over the lip of that cup, that'll signify half a jigger, which is 3/4 of a fluid ounce. And it's been 8 minutes and 30 seconds approximately. And we can see the water, the fresh water, is running off there real quickly. Happy silence. Dripping water, dripping fresh water for our castaways on Gardner Island. Okay, almost there. Just a couple more drops. When it runs over that inner lip, we'll be at the half a jigger, which is 3/4 of a fluid ounce. No, one more. Like watching grass grow, huh, folks? Okay, as we can see, the water is now over the lip, and that marks the half a jigger. I don't know if you can read the line there. It took about 10 minutes and 11 seconds. According to the Air Force Survival Manual, one can survive on 16 ounces or 1 pint of water a day. And it took us 10 minutes to produce 3/4 of a fluid ounce. So let's see how long that would take. Let's see, 16 divided by 0.75. It would take 21 times the amount of time it took to make this fresh water, times 10 minutes. So we're talking 210 minutes, which is about 3.5 hours to produce enough fresh water for one person to survive for a whole day. Now, this is just a small proof of concept device, and obviously Noonan and Earhart could make a much bigger one out of the large piece of aluminum they could harvest off the wreckage of the airplane. So they could make more water quicker or whatever, and so there's no reason to think that the ingenuity of Fred and Amelia couldn't have produced a simple still just as I did here in my kitchen with a normally available type of components. And again, they had 7,000 pounds of sheet aluminum, which makes up their airplane. And I hope you found this informative. Okay, now we got more than an ounce actually, and it's at 12 minutes. Of course, it took 3 minutes for the pot, or 4 minutes for the pot to start boiling. So it's really only 8 minutes to produce 1 ounce once it's going. So let's see, 8 minutes times 16 to get 16 ounces of water would take 128 minutes or 2 hours. Now, it might be boring sitting around tending the fire for 2 or 3 hours, but what else have you got to do? And when you're surviving, that becomes your full-time job. We all spend many hours in the office doing what's necessary. Tending the fire for a few hours a day is in line with that. And I hope you found this informative.